Hello, everyone. Welcome to the working group meeting for HEIR. It has been a very busy week, and I think a lot of people are traveling and at conferences and such. So this one will probably end up being a bit shorter. But we have had a record number of PRs this month, 98, which is, I think, 20 more than we had in previous months. Okay, anyway, let's go through them. So one of the big changes is that now we have backend target config. So this was the RFC I gave last time that got merged, and now we have a handful of backend configuration values. One of the big ones is whether the backend supports a eval Chebyshev and linear transform kernel as a whole that should be preserved by the compiler. And so we finished doing the implementation for eval Chebyshev. Now that will be preserved all the way through to the back end. Both OpenFHE and Latigo support this. And I think this is necessary for the GPU backends that are in progress. Similarly, we have one for linear transform, which is not done yet. There's still one more PR that's needed to put all the pieces together. But only Latigo supports that backend, not OpenFHE. We have a new pass called externalized constants. So this will take all of the large weights that are embedded statically in the MLIR and export them to files and then load them back in at runtime. So we added a new preprocessing.load resource op and a new pass to handle that. The last thing I need to do on this is to port that to the rules HEIR Basel macro thing for external use. Okay, and so we have, so Google is launching a blog post on Friday that showcases some of the things that HEIR can compile. I have been rushing to make all of those demos work over the last month. And there is a long list of sort of random changes, performance improvements, and some hacks that we had to make all this stuff work. Two of the important ones are that we improve the Chebyshev approximation implementation by using an addition instead of multiplication by 2. This matches what Latigo is doing, but was causing us to use a lot more levels than we needed to in some backends where multiplication consumes levels, even plain text ciphertext multiplication. And then we have a new pass called early bootstrap placement. So I had spent a lot of time trying to get the bootstrap placement that runs after all the kernels are implemented to be smarter. But because there are some pretty complex loop structures, the bootstrap placements kept landing like inside loops when it didn't need to be, and I struggled to get them to hoist out properly. So what I decided to do was basically to do an initial bootstrap placement earlier in the pipeline before the linalg operations get lowered to loops. And then both the linalg operations and the polynomial evaluations are atomic operations, and so you can only bootstrap around them. And then those bootstraps are preserved by later passes, and then if there's some issue, there might be additional bootstraps being inserted in between. But because we have a new backend config, the backend config has a new attribute called how many levels does bootstrap consume? And that is in addition to, I think, a config for how many levels does eval Chebyshev or polynomial evaluation consume. And linear transform is always 1 in all backends. But this makes it so that you can actually do level analysis at this earlier stage in the pipeline. And that makes this pass work. So that was a big performance improvement for all these demos. Maybe at some point it would be nice to have a lower level bootstrap placement be smarter. I'm going to leave that to the future work on getting the Orbit ILP solver working. Okay, so we have an intern doing BERT Tiny in HEIR, and it's actually with a bunch of unchecked in code. It's actually working and compiling to Latigo and running in like not terrible but not great time. I think it's like 20 minutes per inference per token. And so it's like, okay, like there's a lot more to do there, but we are like slowly checking in pieces of that, upstreaming it, and we'd like to hopefully get it running on Cheddar at some point in the near future. But some of the things that came out of that were supporting an explicit tensor pad in the pipeline, doing smarter lineage reduce, and basically we have this bicyclic encoding that we're using for doing ciphertext, and plaintext ciphertext matrix multiplication. And that's from Lawrence Lim's paper from last year. And we're doing a bunch of work to basically get kernels to work on that layout system. And that also supports like batch matrix multiplication, which is nice. That's the tricyclic layout. And then on top of that, we added support for softmax. So now we have a new softmax app operation. And then we have support for this thing called CGF softmax. So this is a paper from, I think it was this year or last year. I can never remember the authors or the institutions, sorry. But it basically does an approximation of softmax using just the first 2 moments of inertia of the function. So that removes all divisions, which is nice. And we did a little analysis on like where the precision, like when the precision is good and when the precision is bad. But basically we have like this, and there's one more end-to-end test that I have pending that will make softmax work end-to-end. I mean, the kernel works, but the softmax op is applied on the output of like a reduction. So there's like a lineage reduce op and then a broadcast back along the axis that was reduced, and then softmax is applied. And so that like combination of 3 ops needs a little bit of extra work. And so that PR is what supports that. Okay. There was a lot of work on ISL performance. Thank you, Mark. We were hitting compile time bottlenecks, and it's still, ISL performance is still the worst case. I think it's still like 90 to 99% of the runtime for the compiler on all of our big demos from our demo blog post tomorrow. And I still don't think we have like a good systematic answer. We have a bunch of kind of little trade-offs in terms of like, okay, if the relation looks like this, do this. If the relation looks like this, do this. But one of the big things that we did is add a suite of benchmarks to the repository so that when we make changes, we can at least see how they affect all of the known examples that we have for different classes of inputs, like convolutions of various kinds. So if you're making changes to ISL, please run some of those benchmarks to see how your things impact the runtime. Okay, I don't know how many of these are worth going through. There were a bunch of improvements to handling padding in convolution that fixed some real bugs. We had support, basically just more expanded support for convolutions. Okay, let's move on. So backends, in the different backends, we have a new Pulpy dialect. So this is a new FHE scheme from the author of Latigo, Jean-Philippe. Okay, Boussat. How do you say his name, Mark? Do you know?
Bossua.
Bossua. Okay. So we had a new contributor, Martin Morrow, who is a I think he worked on ZKP compilers previously, and he's interested in learning more MLIR. So he added the Pulpy dialect and the CodeGen emitter that got merged. And I think there's going to be some more, he's going to do some more work on actually lowering some code to Pulpy. There are a couple of new, there's like a CKKS layer that they expose. And then we have to do some additional passes to do ciphertext management in the Pulpy way. But I'd be excited to see how it compares to Latigo on our demos. There's also been some CodeGen fixes for Latigo, some minor improvements on OpenFHE, and then some minor improvements on like the polynomial backend, supporting coefficient form multiplication in RNS and doing more polynomial op folding. We also have some movement on Cheddar. At the end, Mark, I think I'll ask you if there's any updates on Cheddar, but there's some This is the destination passing style for like handling cheddar operations. There's been a little bit of movement on orbit. I think Edward's been out on vacation, but I am sort of preparing to integrate orbit. So I've been adding some new flags that basically allow you to choose between doing orbit style versus like the greedy. This is the ciphertext management solver. So I'd like to, I think one of my priorities in the next couple months will be to push orbit through to the finish line. There's also been a lot of work on polynomial approximation. So we added a specialized exponentiation approximation using Taylor approximation, which has fewer total ops, but is slightly less accurate. So it does repeated exponentiation or repeated squaring versus having like a wide circuit. But I think it's the same level usage as the existing method, but just slightly more efficient. We also added support for math.fpal_i, which is just like x to the power of an integer. So now that was previously, for some reason, converting. This is just a monomial. It was converting it to Chebyshev form and then making a circuit for it. And we're like, well, that's dumb. It's a monomial. Why don't we just do iterated squaring? And so we added a kernel for that. And then Mark added the composite ReLU approximation from the Orion paper, which is very nice. This one is not being used by default. There's a opt-in flag to enable it. Okay, so there's okay, yeah. So this was kind of part of the LLM Berktiny implementation. So we have a bunch of places where we will do a reduction along one axis followed by a broadcast back along the same axis. And the default behavior of this was kind of bad. It was creating a shift network that was kind of inefficient. And so we said, okay, maybe we should just make a joint kernel for a reduce and then broadcast back along the same dimension, because we know exactly what's the most efficient way to do this. And so I added a kernel for this. I have a pending PR that has the actual fused op and recognizing the fused op and lowering the fused op. But then I realized that this was overlapping with some of the work of one of our newer contributors, Alice, who was working on basically the same feature, but without the fused op. So I went back and reviewed her PR, which she cleaned up this last week. And then I asked her if she thought it would be good to reuse the same op fusion thing from my PR, and then maybe we can combine them. And then I looked at her lowering, and I think her lowering is actually better than my lowering. It's more general, and it supports like non-power of 2 size things. So I think we'll go with her thing and then try and fit this in somehow. We also, okay, so the backend config for levels consumed by Bootstrap, that's now integrated into the pipeline. And then we have a new feature. So I thought that this had already been done, but Mark informed me and Alex that it had not been done. So when we encode our plain texts for like plain text ciphertext operations, I thought we were already encoding them directly at the level that they were used at, instead of encoding them at the default level and doing a level reduce op. But we weren't doing that, and there's some missing plumbing through the compiler to support that is added in these 2 PRs. I don't know if that is finished or if there's still some work that needs done on that. Mark, I don't know.
No,
like,
I
has this
think it's
been tested end to end, or I'm just forgetting?
Yes, I tested it on, like, for example, on the Lola test, it reduces memory by 30-something%.
Okay, excellent. Yeah, okay, so I guess that's this most recent PR. I mean, I reviewed it, but I forget because there have been 98 PRs.
Because there are so many of them.
Exactly. No. Okay, so there's a number of cleanup and tech debt. So we finally renamed all of the weird flags called ciphertext degree or ciphertext size or anything like that. Now they're all called minimum slot count. And this is trying to express the user expressing how many slots they need semantically for their representing their program. And that can be increased by the compiler to meet 128-bit security. We also added validate scale and validate level passes that you can run at any time that will do the analysis of the IR and do a hard fail if the scale has an error or the level has an error. And I inserted a couple of calls to this throughout the pipeline as spot checks while I was making improvements to like the bootstrapping passes and stuff. We also, so now we have a new analysis called Bootstrap Waterline Analysis that was added to help with improvements to the bootstrapping pass. And now we have the backend config for how much levels Bootstrap uses goes into Bootstrap Waterline. So I think maybe I didn't mention this, but there have been some simplifications. There used to be a flag called Bootstrap Waterline that was needed to be set alongside the level budget flag, and now the Bootstrap Waterline flag does not need to be set at all. By default, it will just do the right thing. And the reason was because we were missing the information of how many levels the Bootstrap was using, so we had to kind of cheat. So it should just be a lot of cleanup there. I noticed that the MNIST test in the code base was that was using Rotom also had the Bootstrap Waterline set incorrectly, so it was bootstrapping in the middle, and that made that test very slow. And then there have been some improvements to how we handle affine for loops in various places in the pipeline. So there have been some, you may have noticed there have been some timeouts in the build buddy workloads. So sometimes GitHub Actions CI will fail. I've been going back and forth with the build buddy staff. They have a great support on Slack. And I think I have one more PR that's coming out this morning that should hopefully fix it. Basically, GitHub Actions will have connectivity issues that will cause it to lose the connection to the build buddy server, and then it will look like it's just in the middle of compiling one file for 20 minutes, and then GitHub Actions will time out. And so there's a couple of Bazel flags I can set, and then the proper fix is to upgrade to Bazel 9, and we're waiting on the OR tools dependency to upgrade to Bazel 9 before we can upgrade to Bazel 9. And that's supposed to happen mid-September. So in the meantime, we can set some flags to probably improve the issue somewhat. But yeah, anyway, so I'm just working on it. And then I I changed the HEIR README for the quick start. Previously it said install the Python package and run this code. But that is now broken because you need to also install OpenFHE on your system for that to work. And I feel like the Python package has just kind of been lagging behind the rest of the stuff we've been doing. So I put the default thing for the quick start is to try using rules HEIR, which is closest to production. And then I gave alternatives, and then I basically moved all of the code samples to the website so that you would be routed to the website for a full quick start information. It would be nice at some point to really have a one-click hello world demo, but I think to get there we will need to have an end-to-end binary instead of having HEIR opt and HEIR translate and the kitchen sink all the passes. Instead we just have a Clang style binary that just works for one type of program, like only Torch or something, or only JAX or whatever it is. But that's probably going to happen later this year. We're not going to get there yet. In progress PRs. I have still been slowly kicking around on getting emit-c to work for the OpenFHE backend. It's almost there, but I'm just not able to prioritize it at the moment. That specialized Taylor exponentiation, I had a PR that was just experimenting with precision so we could understand more about when it was better to use it versus when it's better to use the defaults Carathéodory CF or Carathéodory FAIR approximation. This was the aforementioned Alice's work on lowering lineage broadcast. This was the aforementioned work on softmax. I don't know what this is. I think this might be some of Asra's leftover work from Lynette. This is continued work on trying to get the cross/jacksite CKKS TPU work as a backend for HEIR. So this was Eric's work on adding loop support to polynomial multiplication, the NTT solver. So this is needed if we're going to keep all of our kernels rolled, like a key switch kernel, for example. And I think it's almost ready, but there was one piece of feedback that I think he would need a little bit more time to work on. Let's see, this, I don't remember what that is, but there was I think it was a small fix for one of our demos. And then this was the last PR in preserving linear transform op for the Latigo backend. If I have time, I'll try to get that in today. I think it's almost there, and yeah, that should be good. And I'm surprised we only had 2 new issues this month. So no one's filing GitHub issues. That's fine. One of them, this was Alex's PR that prompted me to change the name of the flag from ciphertext degree to min slots. And I think we can close it, but there's still like a question about what this flag means semantically and how the compiler is supposed to behave with respect to it. I was hoping Alex would be in this meeting, but he's not. So I hope he will reply on the issue about whether we can close it. The second one is an optimization about plain text ciphertext multiplication. The idea is, I think the idea is to encode the plain text with these, not based on the default scale, but using a scale that is determined by the prime that will be dropped when you do a plain text ciphertext multiplication followed by a rescale. And so if you scale your thing properly, you will be able to have better precision there. And I think that what this issue is missing is that we don't support high precision scale tracking in HEIR yet. This is, I think, something that Alex was working on. I also gave a stab at it a while back and never pushed it through. But that would be unlocked by that. I think this was just noticed as one of the issues with one of the remaining discrepancies between the way that HEIR does plain text ciphertext multiplication and the way that Latigo does it, specifically in the implementation of like the Chebyshev kernel. Okay, that's all the main stuff. Now, I was going to open the floor for a big discussion, but it's just me and Mark today. I did want to share some updates with Google. So Asra's last day was on Friday of last week, and she is taking a big vacation and then leaving Google for a new role. So she says she still wants to help out with HEIR. I'm not crossing my fingers because I know people get busy when they get new jobs, and yeah, so we'll see. But the update on our team is that we may not get backfill for her for a while. There's a lot of politics about hiring at Google, so we'll see. But that means that, like, at least because she's not going to be writing code every day on HEIR, our feature velocity will probably slow down a little bit. And I will need, my biggest blocker with Asra not being here is that I don't have someone to review my code every day. And so I will probably need to lean on the community a little bit more for code reviews, which will also slow it down, right? Just because of time zones. So that, okay, take all that for what it's worth. And if you have friends who want to get into HEIR more, I would love to ramp up some new community contributors. Also, starting Monday, I'll be on vacation for 2 weeks. I'm not sure who will handle office hours, but in the worst case, I will just cancel them and we'll start again in September. And then we have, as I mentioned, we have this big corporate blog post coming out Friday. Keep an eye out for that. I'll post the link in Discord and on social media and stuff. And then that is corresponding to, so it's not going to be highlighting, it's going to be highlighting HEIR, but it will be pointing to the fully homomorphic encryption repository. So this repo has been repurposed from the Google transpiler, which has been archived, to demos of running HEIR that take kind of too long for us to check in as tests into HEIR. And actually, since we improved the performance so much on some of these, I think we probably should migrate some of them to tests in HEIR, like the credit card fraud demo. This is live, so you can look at this now if you want a sneak preview. But like, we have a credit card fraud demo that I think runs in like half a second or something. So it's definitely something we could put into HEIR as a test case. Some of the bigger ones still take 10, 20 minutes and probably can't be checked in.
What does
I
the fraud detection do? What model is
So
it?
it's just a like a fully connected layer. There's a Kaggle data set for credit card fraud, and it's like a slightly more complicated than MNIST fully connected model. So it's very simple, but it's like a real use case.
Yeah.
And then yeah, we have a couple of others in there that you can check out. I did want to share, okay, but I'll just, since I'm just talking, I'll share a little bit about Torch MLAR. So there has been a lot of movement on Torch MLAR recently, mostly because I have been starting up shit about their Python packaging. And as a result of that, there's been like, it's identified kind of a gap in the leadership of Torch MLAR. Like no one is willing to step up and say, this is the decision that we should make for this project. And it seems like the people who used to do that left the project. But now, as a result of me stirring up a bunch of shit, there's all these people coming out of the woodwork saying, no, I want Torch MLAR to work, so I will step up and help maintain it. And so I posted an RFC and blah, blah, blah. But the point is that basically, I think I'm going to be added as a maintainer of the packaging part of the project. And so with, I think next Friday is the deadline for people to raise objections to my plan for packaging. And then I will submit it and then start releasing Torch MLAR on PyPI. And then I hope to get in my annotation thing as well. That is still in review. But basically, I'm taking a small leadership role in Torch MLAR. Great. Given that, I was also thinking that it might be worthwhile for us to have a backend that is not a project that is, or front end that is not a project potentially in leadership confusion. So down at the bottom here, I said maybe we should also have a JAX front end. That would be nice. And I've heard that it's very easy to lower JAX to MLAR because JAX is kind of designed for that from the beginning. But I have someone, a Googler internally who's interested in trying it, so we'll see. But that's sort of my rough plan. And then Mark, if you, I would love to hear an update on what's happening in the Cheddar world.
Yes, so I am but a messenger, but
Okay.
Alex told me that he would open the PR by the end of the week. So,
okay, great.
And
this does raise the question
end
of
of the
how are we
week,
going
meaning tomorrow.
Yeah. We'll see. I mean, I probably won't get merged for another 2 weeks because I'll just be out. But the question raised by this is how are we going to test it, given that we don't have any CI that has GPU support yet. I was thinking of trying to migrate us off GitHub Actions onto BuildKite, and then maybe point that to some GCP runners with GPUs on them, and then Google could foot the bill for those GCP runners. But I have to figure out exactly how and when to do that. So that's, yeah, up in the air. And like, we're going to need the same thing for TPUs when we get the TPU backend working. So either if we can't do that, then the other thing I can do is I can just have a Google internal CI that is easier for us to budget, that runs only after it gets merged in through Capybara. But that's a little bit less good because then if you guys are working on PRs that change GPU stuff, and then you have to merge it in, and then I have to record the errors or fix them myself, and that's just churny, right? Okay, cool. That's good. Okay, so with all of the things changing and with our sort of milestone around getting all these demos working, I think it's worthwhile for us to talk about roadmaps and prioritizing future work. since it's just me and Mark here today, I think we'll save this for the next meeting. Hopefully there'll be more people attending, and I can maybe put a call out on Discord to remind people about this so that they show up and say their piece. But I think that there's sort of like a short list of things that we want to do, and sort of like, at least for me, I think I would want to know like what is the highest priority thing for me to be working on, for the community here. Yeah, so I think that will be a ripe topic of discussion for next time. So yeah, I don't know, Mark, if you have any other questions or topics you want to discuss or shout out to the YouTube viewers, or all 17 of them.
What do you mean by CKKS implementation? You mean lowering all the way
Yes.
to LLVM? So
Yes. Yeah. So I mean, Eric is working on that slowly but steadily, right? Like he's been doing the key switching implementation, and I think all the bugs have been fixed, but we haven't actually run it end to end on LLVM. And so there's and then there's the bootstrap implementation, there's automorphism implementation, and there's just like, I don't know what else there is. There's like a completeness and correctness suite of things that needs to happen to get this working. And then I think that there's probably going to be a lot of interesting work to be done at that lower level in terms of optimizations for specific hardware backends, optimizations, like trade-offs that can be made at that low level. So like, for example, there's like all of the rotation hoisting things where they say, okay, if you're rotating the same ciphertext, then you can hoist out the initial INTT and share it. And like, that's something that we get for free, but we haven't like tested to make sure that that is actually working, if things are happening in the loop, or how exactly that hoisting, we can make sure that that works correctly. And then this leads to sort of the fetch, this leads to the fetch IR, which is a bunch of different groups are working with. And then this also leads to Kornami's CKS thing, in addition to whoever else is working on hardware at this low level. So I think that there's like a lot of additional work to do there, at least in terms of like if you have your IR at the polynomial level, then there's further limitations, like limits on register sizes, right? Like I think the niobium machines only supports 4K degree polynomials, so you have to like decompose your larger polynomials into smaller things. Like I don't remember exactly all the details, but there's going to be some limitations that will need to be accounted for, and that will probably change something about the right CKKS tricks that are used. So yeah, I mean, this one is kind of important to me. I think I need to, one thing I wanted to do was write the world's best tutorial on CKKS, like kind of like CKKS from scratch, and then like use that as an excuse to really teach myself CKKS in a bulletproof way that I can start, actively contributing to the CKKS implementation details, while also, getting myself up to speed on like all of the latest and greatest tricks. Like there's what's it called? It's like sprouts. What's that? There's like the CKKS scaling thing. What do they call it?
Yes, sprout. Yes, sprouts. Yes.
It's not called grafting. It's called grafting. And then they have the concept.
Yes.
Yeah. So like I wanted to learn all these things for a while. So I'm like, okay, I should just like, if I have no one to review my code and I have like extra downtime to like build up my own foundation for things, like I should just like get up to the forefront of CKKS research and really, and like learn about all of the like CKKS functional bootstrapping stuff. And I mean, we had this new ship bootstrapping algorithm that we did in TPU, but I have only been kind of like slowly following the work because it was sort of Asra's intern. And he's done now and she's done now, so there's no one left to push that work forward except me. So like there's like
or
a lot
to tell
of
you
Yeah, exactly. So there's a lot of like CKKS stuff, like my own CKKS knowledge that is limiting me from making progress on all these different forefronts. Um, and of course, there's the TPU backend, right? Which is there, but I think it's not there yet. It's not like ready yet for prime time. So there's sort of a lot of things that I could be working on, and having good CKKS knowledge is limiting me in for a bunch of these. But yeah, so I mean, there's also like other GPU backends, like Cerium, Cyclops making it like an official backend, Cheddar, there's all these different GPU things going on. But anyway, okay. So yeah, I think we should have a long discussion about like what are the highest priority things to work on. And that means that all of the startups working on FHE need to come and yell at me for to lobby for their favorite features, and then I will listen to whoever is the loudest, and I'll figure something out.
How it usually works.
Yeah, exactly. How politics usually works. But anyway, so yeah, okay. I think that's it. Thanks everyone for watching. Have a good month. See you next month.